Hypersoft sets and their topological spaces. Well, this short presentation contains some basic information on Hypersoft sets and is almost entirely based, as you can read now, on the paper by Musa and Assad published in 2022. You should check the bibliography at the end of this video. Well, their paper deals with topology. They introduce topology on Hypersoft sets, albeit it contains many information about these sets as such. In particular, it contains some basic definitions of algebraic operations. However, as for the initial definition, then it comes from Smarandache. Okay, and in general, Hypersoft sets can be considered as an extension of ordinary soft sets introduced more than 20 years ago by Molodtsov. Assume that we have some initial universe U that contains some objects. Basically, we assume that there is a finite number of these objects. And then we have pairwise disjoint sets, capital E1, capital E2, and so on, capital En, and disjoint sets of parameters of some criteria. We do not specify their nature. In practical applications, there are mostly some adjectives that describe certain properties, possible properties of our objects, like being ugly, being beautiful, being old, being new, being expensive, or something like that. And then we have other sets, AI. Each AI is a subset of an appropriate EI. Yes, and then we have pairs of the following form: F associated with the product of A1, A2, and finally AN. And such pair of this form is called a Hypersoft set over U, where F is considered as a mapping, as a function that takes n arguments exactly from this product and returns some subset of U. So this is just like a soft set, but instead of one set of parameters, we have a product of n subsets of parameters. For simplicity, we may write F and A with this font. So each Hypersoft set can be described in the following way, with the assumption, of course, we should remember for the whole time that such alpha is an n tuple. And this example was prepared by me. Assume that we have the following sets of parameters. Capital E1 contains two properties, that something is cheap or something is expensive. Capital E2 contains two adjectives that refer to the notion of beauty, beautiful and ugly. And E3 contains only one parameter, namely E5, that something is in a good condition. And our universe U consists of four houses. Okay, our E is just a product of this E1 and E2 and E3, capital E1 and so on. And we can interpret this, and we can define the following two Hypersoft sets, and of course many other Hypersoft sets, but in particular these two that are presented below. And each of them can be considered as a description of some decision maker, or rather of his point of view. For example, we could think that decision maker F thinks that, as we can see, this house, namely H1, is the only one that satisfies these three parameters, these three properties, that it is cheap and at the same time beautiful and at the same time in good condition. But for example, if we are looking for some houses that satisfy these three properties that are listed here, E2, E4, E5, being expensive, being ugly, and in good condition, then, well, in the opinion of decision maker F, this set is empty. There are no such houses. Okay, and decision maker G has his own Hypersoft set that describes his his point of view, his opinion on this topic. If we have two Hypersoft sets over the same universe, then we say that one of them, say FA, is a Hypersoft subset of GB if its set of parameters is contained in the set of parameters of G, and if for each alpha, for each n-tuple of parameters alpha, f of alpha is contained in G of alpha. This is very standard definition, clearly, of course. As for the complement, it is also very standard. We just take complements of standard complements of each f of alpha for each alpha. As for the union, it is defined in the following manner. If we have some parameter, some n-tuple of parameters that is denoted by alpha, then we just add corresponding sets taken from Hypersoft sets f and g. Okay, but what is specific is that C is considered here as an intersection of A and B, not as their union. Other approaches are possible too, and they are described in the literature, as you will see at the end of this video. There will be the bibliography. As for the intersection, this is also standard, and in this case it's rather natural that we have A and B, namely the intersection of the sets of parameters. Well, in both cases it seems that these notions can be defined only if this intersection of parameter set A and parameter set B is non-empty, perhaps. We have difference, again, intersection of parameters sets, and then just set theoretical difference here. We say that FA is a relative whole Hypersoft set, so relative universal set if for all alpha in A, f of alpha is like U. We remember that A is, let us recall this fact, is a product of such A1, A2, and so on, and each AI is contained in capital EI, in a corresponding capital EI, but it need not to be identical with EI, so we can use only some of these parameters, and perhaps due to this fact we can speak about relative whole separate Hypersoft set. The same with relative null Hypersoft set, denoted in the following manner. Just as in case of ordinary soft sets, we can define Hypersoft topological spaces, and their requirements are very standard. Well, of course, closure under arbitrary unions and closure under finite intersections, openness of relative null and relative whole set, and that's all. Of course, you can imagine other spaces of this kind, other classes of spaces one could define, and maybe they are already defined, I don't know. Generalized Hypersoft topological spaces, infra, supra, Hypersoft topological spaces, maybe minimal structures or weak structures, why not? Be as it may, an example of such topological space is given in the paper of Musa and Assad, and it is here. You can analyze it and check that all the requirements, all the expected requirements are satisfied here. One can add that many typical topological notions have been already defined in the context of Hypersoft sets by various authors, and for example we have open and closed sets, interior and closure, subspace, the notion of subspace, the notion of continuity, connectedness, also the notion of neighborhood. Moreover, there are some practical applications, or at least potential practical applications, in mostly in decision making, and the idea of Hypersoft sets has been already extended to, for example, fuzzy parameterized Hypersoft sets, but there are also neutral-zophic Hypersoft sets. So this is the whole theory. There is the whole theory. It was described, for example, in this book, Theory and Application of Hypersoft Sets, 2021, but there are also many papers, and some of them have been listed here. We used mostly this paper by Musa and Assad, Hypersoft Topological Spaces. If you are interested in soft sets as such, in general in soft sets, then you should check, for example, paper by Shabir and Naz, but also the initial paper by Molotsov. Okay. Oh, I'm not sure, maybe there is a mistake here, because Molotsov presented his sets not in 2011, but several years earlier. Be as it may, thank you very much for your attention. Goodbye.